And I'm live. That is cool. Today is 28th of January 2026, Wednesday. And with that, let's start reviewing some older questions, problems, not questions. Yep. Let's see. Here are quite a few problems that I've put in um, my review list. Let's see what is this one. Dances, easy. Okay, I did solve this. Also, last year I did this. Okay, and I did this just a few days ago. Yes, this is the easy version of the problem. Given two arrays of integers a1 to an and b1 to bn. Before applying any operation, you can reorder the elements of each array you wish. Then, in one operation, you will perform both of the following actions. If the arrays are non-empty, choose any element from A and remove it, and choose any element in B and remove it. Let k be the size of the both array. You need k be the final size of both the arrays. You need to find the minimum number of operations required to satisfy every element in A is smaller than every element in B. And yes, I did mess up quite a bit in this problem when I was solving on 22nd. And yep, now I would just like to go through this once more. Yep. And what is given is that m equals 1. This problem was too easy, so the problem author decided to make it more challenging. You are also given a positive integer m. Now you need to find the sum of answers to problems of for m pairs of arrays. These where Ci is denoted is the first element in A. Yep. 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 So we can do the easy part, and let's see if we can also do the hard part. Maybe we can do the hard part. Let's see. Start new one. There is some update here and synchronize. Yes. Shit. One more thing. This happens all the time. Keyboard. Yep. Keyboard shortcuts. Function keys. USB keyboard. Caps lock should be control. Yep. Cool. That is control now. And yep, the stream is also fine. Even though this is some error. Cool. We will do this one. I already have its solution, but let's remove that. Okay, we will take in n, and we also have to take in m, n and m, and we have two vectors a size n and b also of size n, and then we will say a0 is always equal to 1, and then for int I equals 1, I smaller than n, I plus plus c in ai taken to ai, and for int reference x in b c in x. Cool. And yep, now we have to sort both of these. Sort a dot begin and a dot end. Paste, find a, replace with b, replace with b. Okay, a and b both are sorted, and int ai equals 0, int bi equals n minus 1, right? And for int, wait, we don't have to keep this separately. Yep. Int ai equals 0, I is smaller than n, I plus plus. Ai. Yep. So we are at the smallest element. Ai is pointing to the current smallest element in the A vector, and bi is pointing to the biggest element in B vector. which is wrong. It should be pointing to the smallest element in B. Now we want the smallest element in B that is smaller than, that is greater than AI, which makes sense. Okay, so while BI smaller than N and BI is smaller than or equal to AI. While this is true, we will do BI plus plus. Now, if BI is smaller than N, then we do have something that is something in B array which is smaller, which is greater than the AI element in A. Therefore, we will say we will also have int rest equals 0. We have one pair. We have to find out the maximum operations. M is 1 in our case, always 1. Okay, BI is smaller than N rest plus plus rest plus plus and BI plus plus and AI is, yep, already plus plus. Then answer would be N minus rest. That should work. It does work. Okay, let's try to solve the hard version of this problem. Round was this, division 3. Okay, this one. Here m can change, m can go up to 10 power 9. M can go up to 10 power 9. Okay, m can go up to 10 power 9. And for anyone watching this is the problem. So in the normal easy version, what we have is A always has 1 as one of the elements, and then all rest of the elements, and B B has all the elements that it has. The only thing that is different in the easy and the hard version is that A in the hard version, this this number, the first number, is changing from 1 to whatever the value of m is. Right, 1 to whatever the value of m is. Nope, it is not. We cannot even run a loop that goes from m1 to 10 power 9. Or can we? The size of array A for each output, the total number of minimum operations required for all the pairs. Total number of minimum operations. Total number of minimum operations. So what is the minimum number of operations when this thing is 1, then this thing, when this thing is 2, then 3, then 4, and dot 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 till m. We have to find the sum of all these minimum number of operations. We already have a way for finding out when the first element is 1, but when its value changes, what are the things that do change when this only number changes? Right now in our solution, what we have is this. There is going to be one, like, smallest number in B which is greater than this first number. Then we move on to the second number, whatever it is, second biggest number in A, and we map that number to something, and then the third biggest, we map that, and we are mapping all of these numbers. And for some numbers we won't be able to map them. Now when we change this first number and increase it, yep, and we increase it, how is that going to change the answer? Let's take an example, this one. This would not affect the answers for all of this. Okay, if here the answer is, let's say, some value x, and changing this would only make the answer x or x plus 1, but not x minus 1. Yes, x or x plus 1. Either we also remove this or we do not remove this, in which case answer is x plus 1. X, yes. So these are the only two values which the answer can have. If we already know that the current answer when first element in is 1 is okay. For this, let's sort this. This is now sorted in descending order. 1 1 1 2 2 3 3 4. And in one case this becomes 2, and in one case it becomes 3, and in the last case this becomes 4. Okay, so for this case answer would be uh, for 1 we have 1 here. The biggest, the smallest number in B that is bigger than 1 is 3. So yes, we can have this in our final array. Then for this one we have this 3, for this we have this 3, for this we have this 3. So we will have to remove these four numbers, and we can keep these four numbers. So the answer is 4, which is how many numbers we have to remove. We have to remove these four numbers. So answer in this case is 4. But here also the answer is 4. Here also the answer is 4, and here also the answer is 4. Answer is always 4, because we all of these first four numbers in all the cases are smaller than all of these numbers in B. Right, right. So this is not a very good example, but here I guess the answer would be 16. Yes, answer is 16. Let's look at this one. This is B. Let's sort this. 8 and 1 1 5 5, and this first element goes from 1 to 7. Paste, paste, paste. 4 5 6 7. Here it is 2. Here it is 3. Here it is 4. Here it is 5. Here it is 6, and then here it is 7. Cool. Okay, in this case we have this these two numbers are smaller than 3. Then we move on to 5, and 5 is smaller than 8. Here we will have to remove this 1 3, so answer is 1 here in this case. In this case, these two numbers, we have three numbers that are smaller than three numbers in that, so answer again is 1. In this case we have this which is smaller than these, and then this which is smaller than this. So we have to remove two numbers. Answer here is 2. Here also same thing, answer is 2. Here also answer is 2. Here again 2, and then here again answer is 2. Okay, so at this point, so we already know that the basic answer, so we can make a theory, and the theory is that for all the values of m beginning from 1 till m, we have answer for the first some values, and then at some point our answer becomes x plus 1. So for most of the, for some time answer is x, and then answer becomes x plus 1. We just have to do, we have to find out this point where the answer changes, and we can use binary search for that. Shit, yes, we can use binary search for that. We can find out the basic x answer, and we can find out the answer when we can find out the answer when uh, m is equal, when the first element is equal to m, and then using binary search we can find out this point, and then we can find out the area here and the area here, and that would be our answer, the sum of these two areas. Okay, let's solve this more difficult one. N and m, and we will have a function int, not find, get, this takes in two vectors a and b, rest equals 0 and bi equals 0, and we will assume that these two vectors are sorted. For int I equals 0, I smaller than n, I plus plus. What is n? N equals a dot psi y bi smaller than n, and b bi is smaller than or equal to a I bi plus plus. And then if bi is smaller than n within the range, then this plus plus and bi plus plus return n minus rest. Okay, we have a function here, and then we need two vectors a size n, b size also n, right? And then ai equals, what is I? Yeah. And okay, for int I equals 1, I smaller than n, I plus plus, cin taken to ai, and for int reference x in a, cin x, right? And yep, dot a dot begin dot n, right? Sort a and b, and int x, let's say, is get answer for a comma b, this thing, and yes, answer for this is, this x is our basic answer. And now we have to find out the point at which this change happens, right? But we let's also keep a copy of b, of a, auto a c, a copy is a, right? And then we will sort this copy. Yes. Yep, now okay, now a C0 equals m and int x m x maximum or next is AC comma B. Now there are two cases here. If xm is greater than x, then something else, we have something else. Okay, and let's end this equals 0. No, not 0. Res would be equal to m. There are total m cases multiplied by the base answer. That makes this long just in case, and into one long. And see out res. And if this is the case, then we have to find out the point at which our answer increases. So int L is 1 and R is M. And what we do know is that at L we have the smaller answer and at R we have the bigger answer. So L is outside our range and R is inside our range. R is included but L is not included. So while R minus L is greater than 1, sort A. Yep, is this, then int M equals L plus R minus L divided by 2, and we have to get the answer when M value is shared. MD, middle value, is this, which would be auto AC, let's say, equals, or AM equals A, and AM 0 equals MD equals MD, and sort A dot big AM begin and AM dot end, and if get AM dot B equals X, then we know that this thing is also not in our value, and L equals M, else we have R equals M, and when we get out here, answer response plus equals M minus R plus 1, and hopefully this is correct. Let's see, and this is not correct. This is horribly wrong. A dot begin sort AC. Yes, because after doing this we have to sort AC dot begin and AC dot end. Okay, that is also wrong. Hello. Shit. Uh, you have your GE paper today. All the best. And shit, why are you on YouTube? Maybe you can go and do some meditation and then give your paper, and all the best. All the best. I hope you get your maths and physics right. And for chemistry, we actually have to hope. We cannot see anything about chemistry. Yep. All the best. And here, shit. sort am dot begin am. M is 4. 4 is actually crazy. M is 4 and X is 1 in this case, it seems somehow. 1 and 2. See out what is the base case for these? Yeah, 2 is wrong. Wait, rest is 0. Why is rest 0? Bi equals 0. Okay, ai. Bi is smaller than n, and bi is smaller than or equal to ai. B increase bi. Yes. 2 minus 0 does not make sense. Y is res. Y is res 0. Vi is smaller than n. Increase res, and this should be false because 2 and 1. Yeah, this compile. We just have one test case, 1 and let's say 1, and then 1. Shit. Compile one test case, two numbers, 1 1 2 3. 0. Res was equal to 0, so 0. Y was res equal to 0. Res should not be equal to 0. Here res should be equal to 2. C out B and A. Compile. We just have one test case with two numbers, 1 1 and 2 0 0. 0 0 is messed up. Y is A 0 0. A 0 is 1. Yes, and get is being called here. Compile. Something is wrong. Before calling this get function, see out print A and B, and don't print A and B here. One test case, 2 1 1 and 1 and 3 2. Okay, 2 and 3 is okay, but why is this thing? N and M. N and M. I equals 1 till smaller than N. Yes. Okay, because this should be B. Okay, that was stupid. And now this should hopefully work. Or compile time error? What the hell? Shit. Time limit exceeded somehow. While R minus L is greater than 1. If bit be L and R. We are not getting out of this while loop somehow. Even though we are changing L and R always give the wrong values. Okay, cool. That works, and it should also work here. Last problem, hard version. Let's see. Okay, wrong answer on test 3. Messed up somewhere. We also have this constraint, or should there is a loop invariance. We also have this loop invariance that for L, the answer is X, and for R, the answer is X plus 1. So we know that when we get out of this loop, R is pointing to the first number that is giving us the answer X plus 1. And from then on, all the values will give us the answer X plus 1. Is that a correct assumption? Is that a correct assumption? I think that might be wrong. That assumption might be wrong. Maybe actually the graph that we do have is we go forward for X, then let's say X plus 1 is here, not to scale, then X plus 1 for some time, then X again for some time, then X plus 1, and stuff like this. So maybe there are ranges instead of first X and then X plus 1 always. Maybe there are ranges. And what would this mean? Yep, in B, in the B vector, let's say we know some values, let's say some b1, b2, some values which are being used, and in the middle these values are not being used with anything. And in A, if we do not include our first element, A2 till AN, we have a mapping. A2 is mapped to this, and then A3 mapped to this, and something. And our A1 value is which is changing. And while A1 is smaller than or equal to A2, we can always have A1 while there is some value which is not being used and it is greater than A1. Okay, if we remove all of these values which are being used, and then while we have some value which is greater than A1, we will be able to use that value to keep A1. So which discards this theory, because as A1 increases at some point, we will not have any values which are bigger than A1 in B, in the B array. So we won't be able to use A1 after that point. So therefore, our graph will increase at one point and then stay at that increased height. So this should be working. So what is the problem here? Yes, some integer overflow. Shit. This is long. Wait, is it asking for modulus? No, it is not asking for modulus. It wants the exact answer. Right. It's 10 power. The difference is that, yes, the change in value of m. We messed up somewhere. Where did we mess up? Okay, all of this is long long. Let's change this to long long so that we don't have to multiply here by long long. Okay, yes, here get, wait, no, no, get is fine, get is fine, get is, yes, get gives us a integer that is at max equal to n, and n is not very big, n is 10 power 5 at max. Right, so sort is also fine. This is also fine, and if x greater than xm, this is the only point where we are adding something. This should be also work. So the only thing that we have changed is we have changed this m to be a long long, and maybe, just maybe, when we were multiplying things here, that got out of bounds. Or wait, yes, this is what we had originally. This gave us the wrong solution. Maybe, I think if I remove this from here and put multiply here, now we will have this like properly. Now maybe this will work. Let's see. Yep, that was the error. This thing. So we have an insight overflow.cpp into main. If we have an integer n equals some big number like 1e7, and then end n equals 1e7, another big number, and we have long long res equals n into m into 1 long long. This will fail. This will give us integer overflow error, and if we do cout res, we will get the wrong thing. What is cout? Good question. Bits c c plus plus started and using space actually. But if we were to do rest 2 equals n into 1 long long into n, we were to put this multiply by 1 long long before doing the operation which is giving us out of bounds, then I think we will get the correct response. Compile and run. And yes, here we do get an integer overflow when we do this, and when we do this we do not get an integer overflow, because first we are making this n, which is an integer, into a long long by multiplying it by long long, and then we are multiplying that long long integer value, long long not integer, long long value with m. So we are not getting an overflow. Here we are multiplying a big integer with another big integer, and after the shrinkage we are converting it into long long. So that was the error, but now it is gone, so cool. And yep, cool. We can remove this number, this, from review. Cool. Let's move on to another question, problem, or review. Hello. Yes, camera lagged, now fine. Okay, my bad. And this, okay, I have done this, but this is just in review for some reason. Let's see why. You are given an array A of length n consisting of non-negative integers. You have to calculate the value of, okay, shit, yes, this was a good problem. Yes, this one was a good problem. We have to write a formula for this. Yes, this was a good problem. This was a good problem. This was a good problem. Okay. Yes. FLR is the XOR of all the numbers in array A from L to R. L and R both are included, and R, yes, this is the like size of the range. Okay. Okay. So we have an array A. This is like actually cool. Yep. What we have to do is for each subarray, or let's say summation L starts from 1 goes till n, and for that summation R equals L goes till n, and what we are doing is R minus L plus 1, which is the size of this range from L to R. How many elements are there, where L and R both are included, this thing multiplied by XOR of all the values, multiplied by AL XOR AL plus 1 XOR dot 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 XOR with AR. This is what we have to calculate, and this is very good. This is a very good problem, as it took me a few days to understand, but this one is pretty cool. So what, we cannot do this directly using brute force, because this summation goes, we have also this summation goes from 1 to n, and when for each value of from in this range 1 to n, R will go from L to n. So in total, the total number of times that this loop will run, if we were to do this using brute force, it would be 1 plus 2 plus 3 plus dot 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 plus n, that is n into n plus 1 by 2, and that is big O of n square time complexity, and n here is 10 power 5, 3 into 10 power 5, which is 10 power 10 time complexity, which is quite a lot, and we cannot afford that much time. So what we have to do is for each value of L, we do not want to change this R. We want to find out for each value of L what is the answer for all the values of R, or vice versa. For one specific value of R, which is going to be in range 1 to n, what is the summation of the answer for all the values of L when R is equal to some specific value, and we are going to be finding. And if we were actually going to do this using brute force, so first of all, this loop, this part is going to run n square times, and this part itself, if we were actually going to do this using pure brute force, this part also takes up n time, because we will have to go through the elements and take their XOR. So into n, this is the number of loops, how many times a loop is running, and this is how much time a single loop takes, a single iteration takes to run. So in total, the time complexity would be n cube, which is worse. So we can first of all mm, do this in constant time by having a prefix of XORs. Let's do that. Wait, what is this? This is the example. Yep, never mind. Okay, I already have this here. Wait, this is not mine. This is not mine. Constant expression power mul m long. I think I copied this code from someone else. Yes, I guess I did copy this code from someone else. In my last submission, did I submit this code? Yes, I did submit. But before that, I must have done this on my own, which I did do this on my own. Okay, let's remove this boilerplate, n, and then yes, int n, c in n, vector int a size n, or int reference x in a, c in x. So first of all, we need a vector prefix. Let's call it XOR n plus 1, where XOR I would be XOR of range 0 to I, where I is not included. Block pointer to non. Okay, we cannot have something named Zor. Zor is something. Let's call it ZR for int I equals 0, I smaller than ZR smaller than N, and I plus plus. And here we will say ZR I equals, or ZR I plus 1 equals Z A I XOR ZR I. Okay. So we now have a way of quickly calculating the XOR in some specific range. This can go up to 10 power 9, which is fine. And we also have to take the modulus. Now we have to write a function, and we have to write a function that shade. Okay. In this, answer for 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 this, then this, and then finally the whole thing, and then our L moves forward. We can rearrange. We can rearrange and look at something better. If we have, let's say, n equals 4, let's say, yep, for n equals 4, our whole answer, since what we are calculating for a specific value of L and R is function L comma R, function L comma R, and R minus L plus 1, the size of this range. Both L and R included. For n equals 4, when L equals 1, we will have 4 values of R equals 1, 2, 3, and 4. So F1, 1 into 1, range is 1, plus F1, 2 into 2, plus F1, 3 into 3, plus F1, 4 into 4. Yep. And then for L equals 2, we have F2, 2 into 1, plus F2, 3 into 2, plus F2, 4 into 3. Then when L equals 3, we have F3, 3 into 1, plus, not comma, plus F3, 4 into 2. And then when L equals 4, we just have one case, 4 comma 4 into 1. For all of these cases, the thing that is being multiplied is 1. We can group them together. For these cases, the size is 2 always. For these cases, size is 3, and for this we only have one case, size is 4. So for when size equals 1, we can group them together. For size equals 1, we are just looking for sum of 1 1 plus F2 2 plus F3 3 plus F4 comma 4, and same for size. When size equals 2, F1 2, F2, 3. We are adding all of these, and then F3, 4. And when size is 3, we have F1, 3 plus F2, 4, and then when size equals 4, we have F1, 4. Yep, we can group these things by size. We can, yes, group these things by size. Take their sum, multiply them by the size into 2, this thing into 3, and then this thing as it is. This thing into 4. Yep. So is there a way to find out this thing, this value, without going through all of these? Shit, I'm like forgetting how I did this, but yes, we will figure it out. When we have size fixed, we can either fix the size, or we can fix this, the first number, and move by the second number. I'm taking XOR. One, two, three, four, yes. F1, 2, 2, 3, 3, 4, 4. We have to fix one thing. Lower bound. Okay. Yes. F1, 2, 2. Okay, shit. This is different than what I thought. I thought a different thing is being asked here. Uh, like if we have L equals 1 goes till R summation. No, not range, not range, but if we have two different arrays, let's say array A which has some values, and then array B which has some values, array A and then array B, and if we are asking about summation from A1 to AN and summation B1 to Bn of modulus of AI minus Bi. This is doable. We have to sort A or B and then iterate through the one array which is not sorted, and using binary search we can do this, but this one is a bit different than that. We certainly do not want to go through all of these pairs of XOR. Yep, we do not want to do that. This value this value is just this value, okay, for for L something and R something. If we do R plus 1, we can say F, let's say G is our function which takes in L and R and gives us um, the answer for one space for this, right? Yes, let's say G is that function, and G for L and R would be F L comma R and then R minus L plus 1, and then G for L comma R plus 1 would be equal to F L comma R plus 1 and R plus 1 minus L plus 1 would be plus 2. And we can also write F L comma R plus 1 equals F L comma R XOR with the rth value, with the new R plus 1 value. So G with white, G L comma R plus 1 equals this thing, R minus L plus 2 and F multiplied by FL comma R A R plus 1. But this does not help. Yep, this does not help. This does not help. There has to be some other relation in these. Either we go size by size. Oh, if we have A XOR 2 XOR 3, yes, let's say yes, 1 3 2. If we have 1 3 2 1 3 2 for when size equals 1, we have 1 plus 3 plus 2 whole thing multiplied by 1, and when size is 2, we have XOR of these two values. XOR of these two would be 2 plus XOR of these two values, which would be 1. 1 plus 2 plus 1 into 2. And then size, when size is 3, we have XOR of this whole thing, which would be 0. Which would be 0. We have 1 XOR, yes, 0 into 3. Up. We can go bit by bit. Yes, share. Yes, I think we should go bit by bit. We should go bit by bit. I call it problem and not questions, because I have a bias here. Someone like who is much better told me to call them problems and not questions. Still possibilities, samples. Shit, it was not him. Yes, it was not this article. There was article by Radosh. Competitive programming blog. Radosh's blog. My opinion on how to practice competitive programming. He had an article in which he said, yes. One last tip, I have noticed it observing all the top people on Codeforces at Coders, none of them use the word question instead of problem and task. So don't do it. You won't progress if you will keep calling them problems. Keep calling problems questions. So do not call them questions, call them problems. Otherwise, you won't progress, and there is no rational reason behind this. I'm just like following his thing. Yes, shit, we can go bit by bit. We can actually go bit by bit. My bad. Here, we can go bit by bit. 1 is 0, 1, and 3 is 1, 1, and 2 is 1, 0. So, yes, that is the thing that I liked about this question, this problem, not question, this problem. Okay, we have to do division. Yes, for each bit, we can just like remove this. For this bit, we have to go here in this range, then in this range, then in this range, and then we will make this our starting point, this, and then for last, this. Yep, yes. And this is cool. This is cool. This is cool. Now we can do this when we are only looking at one bit and we have a pattern like this 0 1 1 0 1. When we have a pattern like this, we just have to add the sizes. Right, we will start from this and we will look at, or we will not look at this, but there is a flipping thing that is going on. Okay, for this range, for answers, okay, if I already know the answers in this range, that is when size is 1, how many of these have even number of, have odd number of ones? 3. So 3 plus uh, 3 into size which is 1, so 3 into 1. And then for size 2, how many of these things have odd number of ones? This range and this range have odd number of ones, so 2, there are two things. And plus for size 3, how many of these have odd number of ones? Nothing. There is this range of size 3 and this range of size 3, both of them have two ones which is even, so 3 into 0. And then for size 4, there is only one range and it does have odd number of ones, so 4 into 1, only one range. If I do know this answer and I look at this next number which is 1, this flips things. This flips things. This flips things. How? For okay 1 0 1 1 1. let's say we are only looking at ranges which end at this point and have even odd number of ones. So this is one range. We are talking about this index, and this is another range. And the ranges which end here and have even number of ones would be this range and this range. They have even number of ones. And when I move forward and I see that this thing is changed, now we have a 1. So all of these, or so the ranges which had even number of ones will now have a odd number of ones. For example, in this blue range here will now extend forward till this and till this. Both of these, this range and in this range, starting from here and here, ending here, they have odd number of ones. And these green ranges which had odd number of ones, which started from here and one started from here, they will have even number of ones. Yep, and they have flipped. They have flipped. And in our final answer, I will add this number, the size of these blue ranges and the size of these green ranges. And we will have one more range, new range, which is this, which just began here. Okay, and if we have two variables, even, let's say for this, even the sum of sizes of the ranges, we have even sum and even count. Two things. Even count is how many ranges end here which have even number of ones. So for this particular one, here, for this particular one here, we have two ranges which have even size, this and this. So here we would say even count is 2. But then for odd ranges which end here, one is this and then the other is this, and 0, 7. So here we will say two ranges are like this. Yep. And how do these numbers increase? So even for the next one, for this one would be all of these ranges, even count, will increase by one element. So even sum would become its original value plus even count. And same for odd sum, new sum would become odd sum before plus odd count. And let's write the code for this, which seems like easier to explain. Okay, we are not looking at XOR at all. Okay, for int I equals 0, 0, I is smaller than 32, I plus, because there are 32 bits and we are going bit by bit. Initially answer is 0, answer is 0, and we will have a function which returns a long called get, which takes in a vector of integer a and int x, which is which bit do we have to find the answer for, right? And we have a few variables, long, even or even sum initially equals 0, even count initially equals 0, odd sum initially equals 0, and odd count initially equals 0. In the end, we will return the response. And yep, let's go bit by bit. For int I equals 0, I smaller than n I plus plus. What is n? Comma n equals a dot size. Right, if this, depending on what is the value for this current bit, if ai bitwise and with one left shifted by x. This is the case when the xth bit in the ith element is on. If that is the case, then new even sum, right? And new even count would also become something. New odd sum would become something, and new odd count would become something. What would these be? New even sum would be original even sum plus even count, and even count becomes new even count becomes odd count. Yeah, new even count becomes odd count, and new okay, and new odd sum. No, no, no. Shit. All these even things have, this one is even and this one is even. They have increased by one, right? But they are now odd counts. Okay, so I must up here. Even sum plus even count. That is a new odd count, and new odd count is original even count plus one. These two are correct. This is correct. And this new even count would be odd count, odd count, original odd count plus the count, odd sum plus odd count, right? And yes, and response plus equals be odd count, new odd count. Response would be new odd count, and that is cool. New odd count, yes, and update these values. Odd sum equals new odd sum, odd count equals new odd count, and even sum equals, or you can just declare these values here. New even count, new odd sum, new odd count. This thing can be done for both the loops together. New even sum and even count is new even count. But for this case, new even sum equals new even count. Okay, new even sum would just be old, or even sum, the original even sum plus even count. All of them have increased by 1 plus 1, and yep, new odd sum also plus 1, also plus 1, plus 1, yep, plus 1, because the current array in itself, the current element in itself is also odd. Okay, and here new even count has increased by 1, even count plus 1. New odd sum, odd sum plus odd count, odd sum plus odd count, and new odd count is, odd count, original odd count. Yep, and at the end, return answer. And rest the modulus with n at the end, return rest, and rest plus equals get answer for a comma I and rest modulus with m p out rest, and hopefully this is correct. This is not somehow, because there are no test cases in this. Cool, makes sense. There are no test cases in this. Wrong answer, wrong answer, wrong answer. See out rest, there is some problem with this get function. Hello, what are you reviewing today? Today I'm going through problems which are in this like review section that I added at some point, and the current question is this. The current problem is this one, which is like already here, but yeah. And this is a cool problem. This is a cool problem. Here we are going bit by bit, which seems nice. There is some problem. A dot size even count initially equals 0. See out get a comma I 3 3 3 3. Let's see. We have 1 3 2 and 2, and if we write them in binary 0 1 1 1 1 0. Okay, answer when we are only looking at this these bits 1 1 0 here for 1 plus 1, all of the ranges which have odd number of ones in them, for range for size equals 1 we have these, and for size equals 2 this is the only one, so 1 for 2, and for size equals 3 we have nothing, so answer should be 4, not 3 that we are getting here. Answer should be 4. Okay, let's look at this. Answer should also be 4 for this one also, and the final answer is 12 somehow. Yes, final answer is 12. Final answer is 12, which does make sense because int res or int or long long mm, current response is get a comma I, and res plus equals not get but c, res left with by 1. 12, which is not right. Wait, shit. 1 plus 1 plus 1, 3. Yeah, 0 space. Yes, we are getting 3 here. 3 is not the right answer. Yes, 3 is not the right answer. 3 plus 6, answer would have been 9. So we are getting here 3, but 3 should not give us the right answer. Somehow we are getting 12. 3 plus 3 into 2. Shit, not 1. Shit, okay, yes, that was mistake. Left shifted by 5. Now we'll get the wrong answer here also. Yep, 9. Cool. Now we have to diagnose this function. Okay, for range like 0, 1, 1 or 1, 1, 0, when I equals 0, when we are here, and initially all of these values are equal to 0, new even sum is 0, new even count is 0, new odd sum is 1, and new odd count is also 1. Right, so we do this and rest becomes equal to 1. Cool. Then in the next iteration, we see 1 again, and new even sum. New even sum should be 2. Odd sum plus odd count. Yes, it is 2. Odd sum plus odd count. Odd sum is 1 and odd count is 1. So new even sum is 2 and new even count is 1, which is correct. And new odd sum is even sum plus even count originally, which was 0. So this becomes 1 and this also becomes 1. Right. So we add 1 again to response. So response becomes 2. Then we see a 0, in which case we go here, and when we see a 0, then the new even sum becomes original even sum plus even count, which is 1. So this becomes 3 and plus 1 for this new value. So 3 plus 1 for this 4. Okay, and even count plus new even count is even count plus 1, which is also correct. New odd sum, okay, this is the mistake, I guess. New odd sum is odd sum plus odd count. Odd count is 1, so 1 plus 1 2, and odd sum is also 1, so 1 plus 1 2, and now we should be getting the right answer. We are not getting the right answer. Odd count does not increase. This should be new even sum. Okay, okay. A little problem in like writing out the right thing. Camera blurred. Shit, okay, this happens from time to time. I'll just like stop my camera instead of diagnosing the thing. ICBC? Nope, I'm not participating in ICBC. It is 12 number? Yes, it is. Shit, 12. No, yes, it is 12. The correct answer is 12. And this will work. And also, what all graph and trees algo techniques do you know? You can list them all once. Shit, no, I guess. Can, yes, I mean, n log n always works. It is cool. Shit. Okay, shit. N log n would work. N is 5. And shit, this is probably some out of bounds error. There does not seem to be any problem in the logic. Res is long. Are we multiplying some things? All of these values are long, so that is also cool. Okay, these should also be long. My bad, my bad. That was the problem. Now it will work. Will it work? Yes. Yes, everything else that should be long is long. That's what she said. Okay, and this works probably. And no, you cannot list all the things. You can go to CSES problem set, and wait, I have a shortcut for this. Yes, you can go there and do graph problems from here if you want problems, and if you want to look at wait, weekly handbook. If you want something for algorithms, then you can go to this place, CP algorithm, CP handbook, competitive programmers handbook, and there is a section in this on graphs, basics of graphs, graph traversal, DFS, BFS, shortest path algorithms. And yes, if you want a like a rigid answer, I have read these 3 chapters from the start. I have not read any of these chapters. I do have to read these. I think I've done. No, I have not read these. I've only read these 3 chapters from the start. I will do some streaming someday where I will go through these and I will read these, and that will be cool. And now accepted. Cool. Hello. In implementation, please help me. Yes. Okay. What is your problem? Just change to sign, bro. No worries of long. Change. It is signed, isn't it? If we just, what do you mean change to signed? It is, if we add int, int is by default signed. And if you meant unsigned, then also this would just increase the range from 2 billion to 4 billion, and that is also not long enough in some cases. How you solved? Can you pre-compute the, no, we don't have to go by pre-computing XOR. That is not the right thing to do. We are going here. That is not the problem. The problem is not this signed. I mean, signed looks cool. Wait, shit. What is the spelling? Fine. Yes. This looks cool then this, but this is not the problem. The problem was this. Here, these values, OC and all of these values, these are long values. So these have big numbers in them. But all of these values, they were integers, and integers are not long enough to have long values. So we got error. So we had to fix that. But now it is cool. We can also remove this problem from here. I've read the whole book. Shit. So why are you facing problems in implementation. If you have read the whole book, yes, I can do that, but I don't like doing that. I like to like write it on my own like this, long. This just looks very clear. Wait, if you have read the whole book, then you should not be facing problem, right? And implementation, if you are facing problem in implementation, maybe what you can do is like right now I solved this problem, delete this whole thing and rewrite the solution. Let's do that. And n c in n, rewrite the whole solution again. For int I equals 0, I smaller than n, c in ai. We can do this way or a cooler way, like so. In this part, we have just taken in the solution, and I think this would help your implementation skills. If implementation is the problem, yeah, I mean, but long is better. Should I solve while CACS problems before Codeforces? And okay, this is not like step-by-step guide. Not that Codeforces and then CSES, when one does not come after or before the other, they are like together. At some point you want to do Codeforces and at some point you want to do CSES. Like for example, in some days I am planning to work on my graph skills, and then I will pick up these problems and I will solve them, and I'm not logged in. Okay, no one saw the password. Cool. Yep, I've already solved a few. Then I'm planning to go through quite a lot of these problems. And at some point, I was getting into dynamic programming and then I was solving these problems. So, like, it depends on, do you want to work on something specifically or you just want to work on your general problem solving skills? Right now, I'm working on generally, and when I want to focus on some kind of problem, you can go to CSCS. Yep, lack of practice. Yes, to say it bluntly. Yep. So we forget to declare long. Imagine it happening in. Yes, it is very painful. It is very painful. So that is why you have to be. And that is why you have to know the range of your variables. And I guess a good programmer would know how big a value a variable is going to take, and they will take care of adding long instead of integer. Called shit. Okay, that this has not happened to me. This is very painful. Someone hacked your solution and you got hacked. Shit. How long have you been coding? You asking him or me? I'm in my third year. So yes. 1 year, 2 year, 2.5 year, and not, yeah. And here long rest equals 0. And yes, also just like solve the problem again just after implementing, rewrite the solution. Implementing a problem should not be a overhead, it should be natural. So we have our m, and then we will go bit by bit. I smaller than 32, I plus plus, and we will have a function which returns long get or solve. We can say solve in this statement, vector reference a and our integer x long that's initially equals 0, and long even count equals 0, even count, even sum, odd count, odd sum, and n equals a dot size, and even count equals even sum equals odd count equals odd sum equals 0, and for int I equals 0, I smaller than n, small n I plus plus. Yep. Uh, long, what would be the new even count, new odd, new even sum, new odd count, new odd sum. Yep. Depending on if AI, if the xth bit in the ith element of A is 1, then we do this, else we do something else, and after this, res plus equals new odd sum. Yes, and odd sum becomes equal to new odd sum, odd count becomes equal to new odd count, and even sum becomes equal to new even sum, and new even count becomes equal to, oh shit, even count becomes equal to new even count, and then return rest, and also here rest modulus with m. Okay, and if the current bit is 1, then what would be the new even count? New even count, if the current bit is 1, would be, shit, to go to that thing again. Current bit is 1, and if all of these ranges were ranges which had odd number of ones, so if we extend all of these by 1, they all become even, because if they had originally odd number of ones, now having this new extra one in them will make them odd, will make them even, will make the number of ones in them even if they had originally odd. So new even count would become odd count. Yeah, odd count. All of these odd things will become even. And new even sum, that is the sum of all of these, would become the original sum plus the count of odd. So OP plus odd sum. And new odd count increases by 1. So even count plus 1, and new odd sum, even sum plus even count plus 1. Yep. And if we are in the else case, then new even count equals even count plus 1, because the current one is also even, and new even sum becomes even sum plus even count plus 1, and new odd count become, it just does not change, it is same as the old odd count, and new odd sum is odd sum originally plus odd count plus nothing. And also one more thing, no, not one more thing, it's the last thing here. Long current response is solve A comma I, solve for this, and res plus equals C res, let's shift it by I and res modulus with M C out res, and hopefully this is correct. Okay, this is correct. Cool. Yep, that can help your implementation. 2 months. Shit. Wow, streamer. Shit, and that's why. Okay, and on to the next problem. Look into, what is look into? New Year's gift. I have not done this. We were just doing this 2 days ago. Okay. Wrong answer on 18th is crazy. Okay, let's do this now. Munakarp has n friends and decided to give a New Year's gift to each of them. He has also prepared m boxes to place the gift in. The beauty of the ith box is AI, And yes, this problem is cool. This has a lot of moving variables. The beauty of the ith box is AI. Every box can contain at most one gift. At most one gift. Monocarp wants to give a gift worth at least yi coins to the ith friend. Additionally, he knows that the ith friend will be happy if at least one of the following conditions holds. The gift is in a box with a beauty of at least xi. Beauty is at least xi, and one of these conditions are true. Either the friend is happy because of the box that they got, and to make them happy because of the box, the beauty of the box should be xi, and if we want to make them happy because of the gift that is inside the box, the cost of that gift must be xi, must be zi. Your task is to help Monocarp calculate the maximum possible number of friends he can make happy if he has K coins. Note that Monocarp must purchase a gift for each friend, and the friend may not necessarily and the gift may not necessarily come in a box. N number of friends, M number of boxes, K is how much money Monocarp has, and then the next line has variables, integers, like the cost of each of the box, and there are M boxes 1 to M, and then I lines follow. Each line, at each line we have three numbers. X1 is the beauty of the box that this friend would like to have. Yi is the minimum amount of money that is going to be spent for the current box, for the current person, and Zi is the, like, how much money how much the cost of the gift should be to make this ith person happy, right? So we make a person happy because of the box, or we make them happy because of the gift. So for box, which person should we choose? If we do have a box that can make some, if we have a box with some like cost AI, and this box can make a few people happy, then among those people we will choose the person who is most expensive to make happy because of the gift, and we will do this for every box. Right, so let's do this. Yes, we did this like 2 days ago, but got wrong answer. Maybe this was integer overflow or something. No, this was actually wrong answer. Okay, remove all this. Int n, m, and k. Wait, k is very big, so we have to make this long long. Yes, k is big, so long long. N, m, k, int a size m for each box, int reference x in a c in x, and then we will have a vector of pair. We will call this, let's say, b. There are going to be n things, where we will say bi dot first is box price, and bi dot second is extra money to spend on this person, extra money to spend on this person. Long long, least money is initially 0 for int I, or auto int I equals 0, I smaller than n, I plus plus int x comma y comma z, c in x, y, z, and x, we can just say b bracket I dot first is x, or we can say auto reference c comma d, let's say equals bi, c equals x, and d equals z minus y, which is the extra money required and least money that we must spend increases by y. P minus equals least money. Now k is equal to the extra money that we have. Now we will sort b dot begin and b dot begin and b dot end. So we are first of all looking at pairs have been sorted according to the box that is required to make them happy, and we will begin from the end. We will begin from the end. Yep, we will begin from the end. We will look at the we will begin from the end, which means each person, for each person, let's say these are people circles, these are people, and each for each person we have two numbers. One is extra money required to make them happy. When we have k is our total extra money, so for each person we have extra money required to make them happy. And box price, BP is a petrol company, BP, which is how much should be the price of the box to make this person happy. So either we give them a box with this much price, or we spend amount of money, extra money from our total k money to make this person happy. We have two choices for each person, and we have a list of boxes, one two some, yeah, we have a list of box prices. So this is now sorted, and the maximum box price required by a person is this. And yes, maximum box price required by a person is this. Hmm. Okay. Hmm. Maybe we should we will start from the beginning, minimum box price, and we will use two pointers. One pointer will remain here, one pointer will remain here, and this pointer will move forward till we get to a number that is bigger than or equal to this number, and we will use that box to make this person happy, and we will remove this person from our list. Yes, we will remove this person from our list. But 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 we what we want is, maybe at this same box price we have two people and one person, let's say, requires X some extra money one, and the other person requires extra money too, and we can make both of them, only one of them happy because of the box. And if extra money 2 is very big compared to extra money 1, then we would like to make this person happy, because they would otherwise require a lot of money to become happy. So we would make this person happy and spend less money on this person to make them happy. So we will sort this in ascending order on the basis of the box price, and then if two people have the same box price, then according to the extra money we will sort them in descending order. So let's do that. We have to give a lambda function here, auto pair 1, auto pair 2, if p1 dot is not equal to p2 dot first, then return p1 dot first smaller than p2 dot first, else return p1 dot first greater than p2 dot no shit instead of first we should have second here. Cool. Now this is sorted properly and we are good to go. And ls equals 0. Let's make people happy because of the box that they have. And bi equals 0, the index of the box that we are at, the current index of the box that we are at, for int I equals 0, I smaller than n I plus plus. There are n people, why bi smaller than m, because we have total m boxes, and we should change this from bi to ai. Substitute bi with ai and a bracket ai, while the price of the box is smaller than the box required by this current person. The box required by this current person, which is bi dot, or we can here say auto box and extra money equals bi, and this is a reference. We will do ai plus plus. Now if ai is smaller than n, we do have a box to make this person happy, then we will make this person happy. Yes, we will make this person happy. And how do they become happy? Increase the response by 1, ai increases by 1 so that we do not use this box again. And to indicate that this person is now happy, we'll make bx equals -1. I think we are good. Okay, and now we have made all the people happy that we could because of the box. Now we have to make them happy by giving them money. Yep. Okay, so for auto box and extra money in b, if box is not equal to -1, if this person is not happy, then make them happy. And if box is -1, and if k, that is extra money that we do have, is greater than or equal to greater than or equal to the money that is required, extra money, then we will make this person happy, reduce from em and the rest plus plus. Otherwise, if we do not have enough money, then we will just break. We won't be able to make anyone happy. See out. Yes, and it should at least work here, but it does not. Shit. 1. The actual answer is 2. We can make 2 people happy here, but we are only making 1 person happy. We have 11 money, yes, total money, and we must spend 2, 4 and 1, that is 6, 7 money. We will have 4 extra money, 4 amount of extra money. And we cannot make any of them happy because of the box, because box prices are 1 and 2 and the minimum box price required is 3, so we cannot make any of them happy because of that. This one requires 3 extra money and this one requires 2 and this one also requires 2, so we can make Isn't this person happy? Right. 6, 7, 4. We have 4 extra money. 3 and 2 is 5. Wait, something is wrong with the maths. Yes, we can make these two people happy. We can make these two people happy. This one requires 2 and this one also requires 2 extra money. Why are we not making this person happy? Rest should be 0. Here, yes, it is 0. Bx equals -1. Yep. And k, I think I'm messing up with k. This one e plus equals 1. Yes. See out k, the space, and k should be 4. It is 4. So what is the problem? At the end of this loop. Shit, okay. Shit, yes, of course. After this, we have to sort this again. Yes, sort b dot begin and b dot end and use this lambda function auto p1, auto p2, return p1 dot second p2 dot second. Now we should be happy. Yes, we are. This does work, but the solution that I did submit 2 days ago was similar to this and it might also fail. Let's see. Hello. The current rating 1350. Streamer mm, A- uh, AI as in artificial intelligence. Yes, AI equals 0. Shared. Okay, in the variable. The ith index in the A array. Hello. I am good. How are you? Dark gamer. Said, what kind of games do you play? Don't increase AI when what about my job? Okay, I will take, take that into account. Okay, AI does not work. AI does not work. This fails on problem number 2 itself. Shit. Hmm. Are we doing this properly? Hmm. I think maybe we should. Yes, maybe we should. Okay, maybe we actually should. Multiset, we will have a multiset of integers to keep track of all the box prices that we have and bx for int I equals 0. We have in total n boxes I plus plus cn box and a dot insert bx box, and here let's switch these two, and first would be z minus 1 extra money and c would be x the box price, but yes, the box price. So now what I'm thinking is We have a lot of boxes and a lot of people who need to be made happy, and we will sort these people in descending or ascending order, does not matter, in ascending order of the box, in ascending order of the amount of money that is required to make them happy. So if this person requires the most amount of money, then we will look at which kind of box this person wants to have. And if we do have a box like this, then we will use that box to make this person happy. Then we will move on to the second person and so on till the person which wants the least amount of extra money to be happy. We will also give them a box if we have extra boxes. Okay. And if two people require the same amount of money to be same amount of extra money to be happy, then we will make the person which requires a smaller box to be happy, or maybe it does not even matter which box we use. If there are two people, people number one, people number two, yes, proper grammar, and if this person wants X amount of money to be happy, and this person also wants X amount of money to be happy, and but the box, this one requires B1 price for its box, for his her box, and this one requires B2 price. And if we have B2 greater than B1, which person should we prefer to make happy? Depends on how many boxes we have. Yes, depends on how many boxes we have. The box that we will use would be the best box we can use to make this person happy. If this person, for or like any person, if wants a box of minimum cost B1, then from our list of boxes we will find the box with some value, let's say box with some value BC, and BC must be greater than equal to B1, and this will be the smallest value which is greater than or equal to B1. So we will find the lower bound for this box, and that will work. And I think apart from that, we don't have to keep anything in account. Remove this, remove AI, and shit, I think my camera is now working. Which case, dark games. No. Maybe he is dark and just plays normal games. Shit, yes, that is also another way to look at it. And yep, camera has now started working. That is cool. B dot begin, B dot end. Why are we doing this? Okay, least money. Sort A dot B response. Okay, and now we will go person by person from the end. I n minus 1, and while I greater than equal to 0, I minus minus, and remove everything else. Okay, or we can do something even better. Auto reference BI, auto reference extra money and box, and we want to go. Okay, no, we cannot do this. I thought maybe we can go in reverse order using R begin and R end, but we cannot do that here. I greater than equal to 0, I minus, and auto reference extra money and box equals BI, right? And yeah, auto iterator A dot lower bound for box, right? from the list of boxes, which is A, find the lower bound for this current box, Bx. Yep. And if it is not equal to A dot, and then we can make this person happy because of the box that they have. Yes, and we will say the extra money required to make this person happy is int max, very big, and is int max, make this person happy, and A dot erase this box from the list of boxes. Now, before moving forward, we will sort B again. We go through all of these elements, I smaller than n, I plus plus, and if the amount of money that we have is k, if it is greater than equal to the amount of money that is required, auto extra money and box, we don't care about the box now because bi. If we do have enough money, then make this person happy. Let's plus plus k minus equals extra money, else break. Yes, else break. Res is integer is fine. Extra amount of money, extra money, all of these values as integers, these are fine as integers, I think. Yep, just k is very big and everything else is fine. And here also we are just subtracting, so that is also cool. And just 1 minute. Cool. Let's see. And wrong answer. It seems we are able to make everyone happy in this case somehow. How are we making everyone happy? Shake, yes. C is the first value. C should be Z minus Y. And this should be X, the box price. Still wrong answer. We are still making everyone happy here. We cannot make anyone happy because of the boxes that they have. Yes, true, but we are making everyone happy by giving them money somehow. Auto extra amount of money is BI. Yes, KI greater than equal to BI, greater than equal to EX. Increase the response and decrease this value. K is equal to 11 does not make sense. We are reducing value from least money because, okay, we have to least money plus equals y plus equals y, and now, yeah, now, okay, this does work, and let's see. And hopefully we can at least pass 2 test cases. Okay, there is doing nothing. Refresh and okay, somehow something happened to the internet. Stream is fine. Okay, while this is loading, I'll just go to washroom and I'll be right back in 1 minute. And I'm back. Okay, we got wrong answer on the same test case. 18 again. Shit. Okay, wrong answer on the same test case. 18th test case. How is your submissions? Eh, 18th test case, which is computer generated. My answer is bigger than the possible answer. Okay, shit. Yes, shit. Makes sense, makes sense. Okay, shit. This makes sense, shit. Okay. This does not matter, and if k is greater than or equal to this, but before that, uh, ex is smaller than or is not equal to m max. Or we can have some other fail-safe bx equals -1, and here you can also take bx and compare bx, not xx, bx should not be equal to -1. Shit. Select everything, copy, yes. Now submit, and now this will work. This will probably work now, hopefully. Yep, cool. This does work. We can remove, it was this, yes, it was this. New Year's gift, remove this from look into, and delete the whole problem. And we'll just quickly write the solution again from scratch. What do we have? N, M, K, and all the things that come with it. N, M, and K, C, N, M, K. Yep. Mm, we should make this long, 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 and long, long. Least money and vector of integer b m for boxes for int reference x in b, c in x, and then a vector of pairs a size n pair int uh, like this for int I equals 0, I smaller than n, small n, I plus plus. We will have three values here, int x comma y comma z. Take input into these three values and auto reference extra money and box equals AI like person, right? And least money plus equals increment this by y, and extra money required is z minus y, and box is x. Yep, a minus equals least money, and now sort b dot or a dot begin and a dot end, a dot begin and a dot end, a dot begin and a dot end, and second remove this and this, make a multiset of integers called b and int, let's say c. For int I equals 0, I is smaller than n I plus plus, c in c, and we dot insert c. Now we have to make people happy because of the box that they have. For int I equals n minus 1, I greater than or equal to 0, I minus minus. So to make this current person happy, uh, before making them happy, auto reference extra money and box equals a I, and auto iterator from the boxes lower bound bx and this box, and if iterator is not equal to b dot, and we can make this person happy because of the money that they have, and we can say bx equals -1 and erase plus plus, and b dot erase this box from the list, and then for in I equals 0, I smaller than n, I plus plus, or if for auto extra money and box in a, if k greater than or equal to money required, and also bx is not equal to -1. If we have not already made this person happy, then k minus equals extra money required, that is plus plus. See out the response, and wrong answer. Shit. Is equals -1 to around. We have sorted a extra money, least money, long least money, c n k n m k b multiset of integers, c insert b, a fill a, sort a, yes, and then response initially 0, B dot erase IT. IT is not equal to B dot end. If we do have a box to make this person happy, we will make them happy by, yes, we will make them happy by using this box. And yes, if Px is not equal to minus 1 and K is greater than equal to extra money, then use that money to make this person happy. Ex and Bx should not be equal to minus 1. Yeah. Yes. Why is this wrong answer? Wrong answer does not make sense. It should be 0. 3 is crazy. If Ex, Bx, Ex, Bx, Ex, Bx. Lower bound Bx. Okay. And we print up here like this. No, we cannot print up here. Wait, but this does not make sense. We are beginning from the end and going till the start. Auto get the box. Then minus extra money required is minus. We need minus money because here is the problem. This has to be M instead of N. Now we should be happy. If Bx is not equal to minus 1 and K is greater than equal to the extra money required to make this current person happy, then we will make this current person happy. K minus equals least money, and least money is being increased by Y. Yes. Extra money and K. Extra money in K is negative. Does not make any sense. Makes sense. K minus equals 1. Cool. Cool. We did that, and now cool. We have a few more questions to review. Or how much time is it? 2:30. Yes, I guess we can review them tomorrow. But tomorrow is also a contest, so that is going to be cool. Tomorrow is a Division 2 contest, and Firefly. I've heard of Firefly. Bowsy. I have heard of Bowsy Firefly from New York, from 03F Club, which has all these people. Looney is the number one person, highest rating. Firefly is the fourth person. Pain. Shit. Uh, like fire flies to a flame. Life begets to death. Shit. Philosopher. Pro is online right now. Give me some heart. 49 problems. Hmm. Yes. Yep. If I want to get as good as this person, I have to work much harder. 1000 problems. And contests. Firefly became expert on his or her sixth contest, that is something, and became a specialist on his or her fourth contest, which is pretty cool. And Bro got rank 200 in their first contest. Crazy. Division 2, one problem solved, became pupil. Then Division 2, three problems solved, became a specialist. Three problems, okay. And what was the time then for these three problems? Bro messed up in the later ones, but time 1 minute. Yes, shit, crazy. 1 minute for problem number one, and then 9 minutes after the contest is started, and then 20 minutes for problem C, which is crazy cool. And this was back in 2024. Cool. Okay, yep. And also, yep, this would be the end of today's stream. We will do some more review questions analysis tomorrow. And tomorrow is a contest, so yes, a division 2 contest. Registered friends, no one has registered among my friends. Bowsy, okay, bro also skyrocketed. International Grandmaster. And PP and let's see which sections are remaining. I've gone through these. Yes, they are pretty good. Good. Complete search, greedy, dynamic programming. Yes, I have to get into amortized analysis. I've not read much about amortized analysis. Range queries. Yes, yes, I have done range queries, but I have to review. And bit manipulation. Yes. Dynamic DP. Dynamic DP is also crazy. And graphs is remaining from these things. Critical union find structure, Prim's algorithm, tree algorithm, reversal, right? Directed graph, strong connectivity, tree queries, finding ancestors, subtree and paths, lowest common ancestor, offline algorithms, path and circuits, Knight's tools, flows and cuts, advanced topics, game theory, NIM game, and Sprague and Grundy theorem, string algorithms, sweep line. Yes, I have to do like convexel. I don't know convexel. Yep. And for today, this would be it. And thank you for being here. Bye.